beta x will give you the change of phase with respect to space. Similarly, beta y and beta z. Why so? Beta is 2 pi by lambda, rate of change of phase with respect to space. So beta will give you the change of phase with respect to space. For example, if you are taking the wave is propagating in x direction, then you take beta x. It is 2 pi by lambda into, at x is 0. Beta x is also 0. At x is 0. At x is 0. Beta x is also 0. This is with respect to space. Therefore, phase shift is 0. Similarly, when x is lambda by 4, when x is lambda by 4, x is lambda by 4, beta x 2 pi by lambda into lambda by 4, that's pi by 2. It is pi by 2. See here, x is lambda by 4 spacing, then phase shift is pi by 2. Similarly, x is lambda by 2, beta x 2 pi by lambda into lambda by 2, that's pi. X is lambda by 2, then it's pi. Therefore, I can say beta x is giving you the change of phase with respect to space. So omega t will give you change of phase with respect to time, and beta x will give you change of phase with respect to space. And a wave is one which changes its phase with respect to both space and time. With respect to both space and time. So, in any wave equation, we need to have these two terms, omega t and beta x. And the one that generates this kind of wave is an antenna. What does antenna will do? Antenna will convert Vi waves into EM waves. This process of conversion of Vi waves into EM waves is called radiation, and convert back EM waves to Vi waves, which is called induction. In simple diagram, I can say in this way, these are voltage or current waves. These are converted to EM waves. The process of conversion of Vi waves into EM waves is called radiation. We say no, antenna is radiating, like that. The process of conversion of EM waves to Vi waves is called induction. It's called induction. If you see here, this is source. This is antenna here, which is radiating. Here we have voltage or current that is supplied by the source is converted to EM wave. This process is called radiation. Now the wave is propagating. It will reach the receiver side. Reach the receiver side. On the receiver side, this EM wave is converted back to Vi waves. EM waves is converted back to Vi waves. This is called induction. It's called induction. So the main purpose of antenna is to convert these Vi waves into EM waves by the process of radiation, and to convert EM waves to Vi waves by the process of induction. Clear? Now let us see what are the special antennas that you have. The special antennas that we have, we call them as seven sister antennas. The seven sister antennas, in which in seven sister antennas, the first antenna is a folded dipole antenna. It is nothing but two dipole antennas, two half wave dipoles kept in parallel, gives you a folded dipole antenna. Gives you a folded dipole antenna. This is your folded dipole antenna. How it looks like, let me show you how it looks like. Folded dipole antenna, how it looks like, I'll show you. See dear, this is the folded dipole antenna. This is a folded dipole antenna. Two half wave dipoles kept in parallel, which gives you high input impedance. It's a broadband antenna. It's a broadband antenna. And the input impedance of folded dipole, of course for equal radii of these conductors, is given by n squared times of Z11. N squared times of Z11. This is for n-fold equal radii concept. N-fold equal radii concept. N squared times of Z11, where Z11 is input impedance of half wave dipole, which is standard 73 ohm. If you take unequal radii, then input impedance Zin is 1 plus R2 by R1 whole square of Z11. If the spacing is also differing, then Zin is given by 1 plus log A by R1 by log A by R2 whole square of Z11. This is called impedance transformation ratio. This is called as impedance transformation ratio. Clear? This is called impedance transformation ratio. R2 and R1 will, the minimum value to maximum value, it will vary between R1 by 4 to 4 times of R1. R2 will vary as R1 by 4 to 4 times of R1, which gives you impedance transformation ratio of 1.25 times to 25 times. Clear? So this is a very important antenna. For detailed analysis, you please go through Antennas Maha Marathon series. The second antenna, the second sister, is the folded dipole antenna. Folded dipole is done. Yagi-Uda antenna. The second one is Yagi-Uda antenna. Yagi-Uda antenna is a parasitic antenna. Yagi-Uda antenna is a parasitic antenna or a parasitic array antenna which contains parasitic elements. That means elements which are not fed directly. A simple Yagi-Uda antenna contains three elements: one reflector, one driven element, and one director. This kind of Yagi-Uda antenna is also called as beam antenna. If you draw the Yagi-Uda antenna, it looks like this. It's a horizontal rod. This is a vertical rod. This is the place where it is holding this rod. Here is a reflector. reflector, this is a driven element. Driven element is a folded dipole antenna. Whose height is 5% less than the reflector. The driven element, this is a driven element folded dipole antenna. These are the directors. These are the directors which are placed at 0.10 lambda to 0.15 lambda spacing, having a height of 5% less. Having a height of 5% less. This put together are directors. Directors. This is driven element. This is reflector. This is horizontal rod. This is vertical rod. And these are the clamps that hold these directors. These are the clamps to hold these directors, driven elements, and the reflector. These are the clamps, and this is a Yagi-Uda antenna, which is also called as super gain antenna or super directive antenna. Super gain antenna or super directive antenna. Is that clear? Yeah. Super gain antenna or super directive antenna. Third one, very important one, helical antenna. If you want, I'll show you some Yagi-Uda antennas also here. 1 second. Let me show you some Yagi-Uda antennas. See here. These are Yagi-Uda antennas. This is a Yagi-Uda antenna. This is a Yagi-Uda antenna. These are Yagi-Uda antenna which are super gain antennas, previously used for TV reception. Previously used in TV reception. Clear? Third one is a helical antenna. Third one is a helical antenna. Helical antenna can be treated as array of loop antenna and short dipole antenna. Array of loop antenna and short dipole antenna. This is the inner cable. This is the inner cable. This is the inner cable, and cable is fixed like this. This is a reflector. Reflector to ensure, this is a reflector to ensure unidirectional pattern. Okay. These are number of turns. N is number of turns. S is spacing between them. L is length on each turn. S is spacing. L is length on each turn. L is length on each turn. This is the inner cable and this is the outer cable. This is axial length, n number of turns into S. Axial length. Total length is given by number of turns into length on each turn. That's the total length of the conductor, and this is the axial length of the conductor, the length of the axis, length of the physical axis. And this helical antenna can be operated in two modes. One is normal mode. It is said to be normal mode when the total length is far less than lambda. Next is axial mode. Axial mode is a case where circumference is approximately equal to lambda. Circumference is given by pi d is approximately equal to lambda. Therefore, diameter is approximately equal to lambda by pi or approximately equal to lambda by 3. This is diameter of the helix. The diameter of the helix. Got it? So you can operate it in normal mode and you can operate it at axial mode. In normal mode, these are used in Wi-Fi routers. Axial mode, it is used in satellite communication or terrestrial communication. Satellite communication or terrestrial communications. Okay. So this is the major antenna, and because on this antenna today we'll discuss MCQs. MCQ on special antennas. Today's antenna is helical antenna. Fourth, and before we go there, I'll also show you some helical antennas for you. Helical antennas for you. See here, these are helical antennas. See properly. These are helical antennas. Okay. These are helical antennas. See here, these are helical antennas. Your understanding will be more clear when you visualize the pictures. See here how the man is very small before this antenna. Naturally, this will be in axial mode, and this will be in normal mode. This also in normal mode, small antennas. This was the structure I was drawing. The ground plane, coaxial cable, inner conductor spacing, and all that. Okay. And this is a radiation pattern. One second. I'll show you here. Okay. This is the radiation pattern. The helix wire pitch, the pitch, and the ground plane, helix diameter, height. And, this is a radiation along the axis in axial mode. In axial mode. You can also see here the radiation pattern like this. Got it? That's about the helical antenna. Fourth one. Microstrip array antenna. These are antennas which are compatible with IC technology. Compatible with IC technology. These are used in applications like cell phones. Microstrip array antennas look like this. See, this is the design of a microstrip array antenna. This is the patch, this is a microstrip feeder, this is a ground plane, and this is a substrate. Similar picture here. Similar picture here. This is also a similar picture. And the radiation pattern unidirectional here. These are practical antennas. See here, these are the practical antennas. How they look like. This is a square patch. This is a rectangular patch. Each patch will generate different kinds of radiation pattern. Therefore, patches are also very important. That's the fourth antenna, microstrip array antenna. Fifth one is about horn antenna. Horn antenna. It's a feeding antenna that feeds parabolic reflector and lens antennas. Horn antenna can be sectorial E-plane on horn antenna, sectorial H-plane on horn antenna, or pyramidal horn antenna. This is a pyramidal horn antenna. The practical antenna, it looks like this. The pyramidal horn antenna. Types of horn antenna looks like this. This is the H-plane. This is the H-plane sectorial horn. This is the E-plane sectorial horn. This is pyramidal horn, and this is conical horn. One more diagram depicting the same thing. So these are different kinds of horn antennas which acts as the primary antenna, for you to feed the primary antenna that feeds the parabolic reflector antenna or lens antennas. Okay, the sixth antenna is parabolic reflector antenna. Parabolic reflector antenna. This will be in parabolic reflector antenna. The parabolic reflector acts as a secondary antenna, and the horn acts as the primary antenna to which it is the power is fed. This acts as a primary antenna. This sub-reflector. Now this horn antenna radiates like a torch. Radiation is something like this. So here the parabolic dish is converting the spherical wavefront into parallel wavefront so that it can be transmitted for longer distance. This is happening at the transmitter side, and this feed is called Cassegrain feed. Cassegrain means making into two. This is splitting this into two, and the feeding is done. Therefore, this is called as Cassegrain feed. And you can also have a front feed. In front feed, the primary antenna horn will be in front of the antenna and will be holded by rods like this. The front feed, again the spherical wavefront is converted to parallel wavefront. The spherical wavefront is converted to parallel wavefront. Spherical is converted to parallel wavefront. The receiver side, if you take the horn antenna, those are received like this. This is a transmitting antenna, this is a receiving antenna. At the transmitter side, it converts spherical wavefront into parallel wavefront. At receiver side, it converts parallel wavefront into spherical wavefront. This is front feed. Other than this, you will have corner reflector. Corner reflector will be in this way, in this shape, with a corner angle of always 90 degrees. This is a corner reflector. And always remember, for corner reflector, this corner angle is always 90 degrees. It's a corner reflector. Instead of a parabolic shape, we have another shape where this corner is possible. Therefore, it's called corner reflector. Clear? Last is the lens antenna. Last are lens antennas. Lens antennas, just like parabolic reflector, are used for long distance communication, but the only problem is lens antennas are a bit costlier. This is double convex lens antenna. The refractive index is greater than 1. Therefore, velocity is less than c. Therefore, they are called delay lens antennas. Velocity is less than c. They are called delay lens antennas. Here also primary antenna is a horn antenna. The work of lens is to convert this spherical wavefront into parallel wavefront. Work of lens is to convert this spherical wavefront into parallel wavefront. This is the transmitter side. At the receiver side, again this parallel wavefront is converted back to the spherical wavefront. This is transmitter side and this is receiver side. Generally this kind of antennas are a bit costly. These are delay lens antennas, and if you take concave type, this is plano concave type, your refractive index will be less than 1, V will be greater than C. These kind of lens antennas are called focus lens antennas. Focus lens antennas. So these are the 7 sisters dear. This is lens antenna, parabolic reflector, horn antenna, microstrip antenna, helical antenna, Yagi-Uda and folded dipole. So folded dipole, Yagi-Uda and helical. Today we'll discuss MCQs on helical antenna. MSA, microstrip array, horn antenna, parabolic reflector and lens antenna. We'll see some MCQs related to helical antenna. We'll see some MCQs related to helical antenna dear. Okay. Fine. We'll see some MCQs related to helical antenna. Helical antenna is a dash antenna in axial mode. When it is operated in axial mode, helical antenna is a non-resonant antenna. In normal mode, it is resonant antenna. It is a non-resonant antenna. Option B is the answer. Helical antenna is famous for dash polarization. Helical antenna is famous for circular polarization. Helical antenna is the cheapest antenna which can produce circular polarization. And its axial ratio is given by 1 plus 1 by 2n. More n is the number of turns. More is the number of turns, the closer it will be to unity. Unity axial ratio refers to circular polarization. Helical antenna can be operated in dash modes. Helical antenna can be operated in axial mode, where n into L. Axial mode where circumference is approximately equal to lambda. Circumference is approximately equal to lambda, or pi d is approximately equal to lambda, or diameter is approximately equal to lambda by pi, or it is approximately equal to lambda by 3. It is axial mode. In normal mode, these are used in satellite communications and other space probe communications. In normal mode, the total length of the antenna n into L must be far less than lambda. Here the radiation pattern is bidirectional. Here it is unidirectional. It is along the axis. This is perpendicular to the axis. These are used in Wi-Fi router. Okay, helical antenna can be operated in dash modes. 2 modes, axial mode and normal mode. In dash mode, the radiation is perpendicular to the axis. In which mode here? I just told you. When you operate the helical antenna in the normal mode means total length n into L is far less than lambda. Small antenna, then the radiation will be perpendicular to the axis. These kind of small antennas are used in Wi-Fi routers. In dash mode, the radiation is perpendicular to the axis. In normal mode, option A is the answer. Helical antenna is said to be in normal mode when n into L is dash, where n is the number of turns in helix and L is the length on each turn. Helical antenna is said to be in normal mode when n into L is far less than lambda. N is number of turns, L is length on each turn. Option A is the answer. Helical antenna. In helical antenna, if spacing between the turns is 3 meter, circumference of the helix is 4 meter, then length on each turn is, you take a helical antenna, when you consider an helical antenna, this is the length on each turn, this circumference, and this is spacing. This is spacing, this is length on each turn, and this d is diameter, pi into d is circumference. Such circumference is this c, such spacing is this s, and that length on each turn is this l, and this is alpha, pitch angle. Now very clearly this is 90 degrees, therefore this is hypotenuse. Hypotenuse square is equal to side square plus side square. Hypotenuse is under root of side square plus side square. L is under root of 3 square plus 4 square, 16 plus 9, under root 25. Therefore option B is the answer. If the diameter of the helical antenna is 3.14 meter, circumference is given by pi into d. Pi into 3.14 meter. 3.14 is pi. Pi square meter. Option C is the answer. If the spacing between the turns of the helical antenna is equal to circumference, then pitch angle is given by, this is circumference, this is spacing, this is length on each turn, this is length on each turn, this is spacing, and this is circumference, this is pitch angle alpha. From this, if you take tan alpha, opposite side by adjacent side, S by C, alpha pitch angle is tan inverse of S by C formula. Given S is C, alpha is equal to tan inverse 1, which is 45 degrees. Option B is answer. Helical antenna is said to be in axial mode if circumference is approximately equal to lambda, or diameter is approximately equal to lambda by 3. Circumference is approximately equal to lambda. Option C is answer. In which mode of radiation of helical antenna is along the axis? In axial mode, when helical antenna is operated in axial mode, radiation is along the axis. Option B is the answer. Which mode is odd one out? Normal mode means it radiates perpendicular to the axis, axial along the axis, endifier along the axis, beam mode along the axis. B, C, D are same. This one is odd one out. Option A is the answer. Option A is the answer. Which mode is odd one out? Normal, axial, broadside. Normal mode or broadside mode, radiation perpendicular to the axis, or perpendicular mode, all are same. This axial is odd one out. Therefore option B is the answer. Axial length of helix is given by, as I told you, total length is n into L, axial length is n into S. N into S meter. Option B is the answer. Very important question. Very important question. Special questions on or special MCQs on helical antenna. Which mode has narrow bandwidth? Normal mode has narrow bandwidth. Option A is the answer. Which mode has less efficiency? Normal mode has less efficiency. Option A is the answer. Radiation pattern of which antenna is a combination of short dipole and small loop antenna? If you see the physical structure of helical antenna, it is the combination of loop antenna and short dipole antenna. Short dipole loop, short dipole loop, short dipole loop. The radiation is a combination of short dipole and loop is helical antenna radiation. Option D is answer. For loop antenna, winding of helical antenna, alpha is. Loop antenna means, if you draw helical antenna here. This is pitch angle, alpha. For loop antenna, this will completely cover. This angle will become 0 degrees for loop antenna. For short dipole, this will be straight line. For angle will be 90 degrees. For short dipole winding of helical antenna, alpha is 90 degrees. Option D is answer. Got it? How do you wind is important. How do you wind it? Loop antenna, no gap. Alpha is 0. Short dipoles, you make it straight. Alpha is 90. In helical antenna, this is helical antenna and this is spacing S. In helical antenna, if spacing is 0, that means all these rings will fall one on other. It will make one loop antenna. S is 0, it will make one loop antenna. In helical antenna, if S is constant, the spacing is constant. It is not changing. But diameter, this is compressed. Diameter is made 0, spacing is not changing. Then you get a short dipole antenna, small dipole antenna. Only this part will be left out, forming a small dipole. The far field pattern of small loop and short dipole are out of phase by 90 degrees. 90 degrees, 90 degrees. The formula for pitch angle, alpha is equal to tan inverse of S by C. In terms of lambda, you want S derivation, S will be C square by 2 lambda. Derivation substituting, alpha is equal to tan inverse of C and C get cancelled, C by 2 lambda. In terms of wavelength, circumference and wavelength, alpha is tan inverse of C by 2 lambda. In axial mode, circumference is approximately equal to lambda. Circumference is approximately equal to lambda means diameter pi into d is approximately equal to lambda. Diameter is lambda by pi. Diameter is lambda by 3 approximately. Option B is the answer. In helical antenna operated in axial mode has number of turns equal to 100 turns. Axial ratio is given by 1 plus 1 by 2n. 1 plus number of turns 100, more number of turns, the value will be very close to unity. 1.005 axial ratio. Option C is the answer here. In axial mode, circumference of the helix. Now you know circumference must be approximately equal to lambda. But what is the practical range? Practical range is it can go from 3 by 4 lambda to 4 by 3 lambda. 0.75 lambda to 1.33 lambda approximately. 3 by 4 lambda to 4 by 3 lambda. These are questions on helical antenna. And helical antenna is a dash antenna if it is operated in normal mode. As I told you, in normal mode it acts as a resonant antenna. These things we'll try to deal in another class. Unacademy offers two paid subscriptions. One is Plus subscription, other is Iconic subscription. In Plus subscription, you got to have the face time of legendary faculties in the form of live classes, weekly tests, structured courses, unlimited access, rank improved batches and crash courses. In Iconic, you got a personal coach for one-on-one guidance, dedicated doubt clearing educators to clear a doubt, preparatory study material, personalized test analysis, study booster sessions and study planner. If you go for Plus subscription or Iconic subscription, I recommend you to go for a no-cost EMI where total cost will be divided by number of months. Where total cost will be divided by number of months. And also by using a team code KNR10, you'll get extra 10% off dear. Iconic subscription, you have 1:1 live mentoring, increasing your chance of getting a top rank. Accelerate, dear, accelerate, dear, no more breaks. 6 months extension we give with every 1 year of subscription. You can use the code KNR10 for the same. Unacademy Light Series, this is the test series for GATE. The first test starting on March 13. Light subscription is now available for 33% off. 14 to 16 of March, you have unlocked 20 where you have 20% off. This is the scholarship test. Try to go for scholarship test. You get the maximum benefit. If you have any doubt, you can contact our counselor. There is a number for the same. This is Unacademy Ask a Doubt feature. We can ask unlimited number of doubts and you can ask 3 doubts at a time. Get the solution preferred language. Very easy to ask your doubt also. Just click crop and submit. Super combo offer going on. With every 2-year subscription we give away 1 year subscription free for campus placement IT jobs. With every 1 year subscription we give away 6 months subscription free for campus placement and IT jobs. Rank predictor is on and these are the special class features. We have interactive live classes, polls for the learners, raise hand option. You never miss a class when the notification is on and you can download the lecture note then and there. You can access anytime and anywhere. Introducing community, you never miss any update from your favorite educator. Download notes and practice material and share your feedback directly with the educator via polls. This vision, batch for GATE and DSC 2024, electrical explained bilingual. Target for GATE and DSC 2023 for electrical explained bilingual. Evolve GATE 2023 for electrical explained bilingual. Ascend GATE 2024 for electrical explained bilingual. Vision GATE and DSC 2024 for EC explained bilingual. GATE target GATE and ESC 2023 for EC explained bilingual. Evolve GATE 2023 for EC explained bilingual. Ascend GATE 2024 for EC explained bilingual. Thank you all dear. Thank you all for joining. Have a great day. We are always with you for a very good learning experience. Yet GATE Conqueror. Like the class and subscribe it and share among your friends. Thank you all dear.